Hi, I'm Tudor Davies, Director of Technology at Spectrum Signal Processing. Today I'd like to show you a little bit about our VPX product line, which is 3U VPX, OpenVPX. We've got the system running here. This is one of the boards that we actually are using in the system. This is the VPX 1131. We also have the VPX 2131. So the 1131 card is a dual ADC plus user FPGA card. And it's also got, the user FPGA is a Vertex 5 FX130 or 200T. It's got an external GPIO connector connected to the FPGA and also an external clock input. That's optional, you don't have to use that, but you can run on an internal clock or external sample clock or external 10 megahertz reference. So the card is designed in such a way that you can use it in air-cooled format, as we're showing here, and also you can use it in conduction cooling. You can see the gold conduction cooling heat rails. So when you want to actually develop your algorithms, you can do that on this platform. You can take it on the air-cooled platform using the FPGA and analog to digital and digital analog cards, and the single board computer, which is running Linux. It's Red Hat Enterprise Linux. So you can do that development on this platform and then migrate to a rugged version of the same card set, which you can take it up to conduction-cooled level 3 of Vita 47 spec. You can also develop on a PC-based platform called our SDR 2010 platform, which uses the same modules. So the VPX 1131 card, it consists of a carrier board and the XMC 1131 module. There's the front of it. You can see the the FPGAs, and you can take that same card and mount that on this PCI Express card. So this PCI Express card is called S-Spectrum's Pro 2910, and it actually has two XMC sites. So we've got an XMC card mounted on here, and we can also mount another one on the back. So in the PC platform we have two cards, two analog to digital and digital analog cards with the FPGA processor mounted on the same carrier board. So what this lets you do is rapidly migrate between the PC-based platform, the air-cooled VPX platform, which is a little bit more rugged than a PC, and you can go all the way to the conduction-cooled platform, which is very rugged for harsh environments. So having the ability to take the algorithms that you developed in one platform and migrate them to the other gives you the ability to deploy pretty much the same software on multiple environments. So the PC-based environment is popular. You can have it in the lab. The costs are low. There's lots of different algorithms and different software available for them. The single board computer running Linux is very similar to a PC in its operation. And we're running the same Linux on this one. It's a Red Hat Enterprise Linux as we ran on the PC platform. So you can develop on one platform and migrate to the others. And so if you're in the lab, you might want to choose a PC where you can use larger processors. You can have big Xeon processors and things like that. In the single board computer, typically they have processors that consume less power in order to be able to operate in the more rugged environments. So all these platforms use essentially the same software. They use the same modules. Obviously the modules would be changed in format for conduction cooling, and they're available with commercial grade and also industrial temperature range FPGAs and other parts on them. So what you can do is develop on the PC in your lab environment, migrate to this with the same software, and migrate to the conduction cooled with no change in software. This demo that we're running today was developed on a PC-based environment, and it was ported onto the 3U OpenVPX environment in 2 days. The difference, of course, is that here you've got two XMC modules mounted on the same carrier card, and here we've got two XMC modules mounted on the same carrier card, and two XMC modules mounted on the two different VPX carrier cards.